practice in healthcare, as we know, in many ways of application. And always happy to support up-and-coming students who are already showing strong leadership and remarkable accomplishment in the field, such as Abdullah. So we very much look forward to his presentation this morning. And for those HIMSS members who are on the call attending this webinar, just a gentle reminder in a positive sense, this allows you to claim or entitle you to a credit education unit, 1 CEU, towards your CP-HIMSS recertification education requirements. So keep that in mind. Make sure you keep track of this webinar, and I'll pass it back to Jesse and over to Abdullah. Thanks very much.
All right, thanks, Grant. Great partnership with such a great organization, and I did leave a link in here if anyone wants information on HIMSS and the Canadian Prairies chapter. And with that said, I'll pass it off to Abdullah. Abdullah, take it away.
Okay. Thanks, Jesse and Grant, for this introduction. I will share my screen now. Okay.
Just so everyone knows, we will be recording this session, and we'll share a link to the YouTube video shortly.
Okay. Can you see my slide now?
Yeah, we sure can.
Okay, perfect. Okay. Thanks everyone for attending today's webinar. My name is Abdullah Sarhan, and I'm a Ph.D. candidate in database lab at University of Calgary. I have been working in the field of machine learning for quite a while, I'd say. And today I will be going over some of the projects I have been working on. I won't go into so many technical details. I will just to make it smooth as possible, and if anyone wants like more information or more detail, I would be more than happy to explain that. So on today's presentation, I will go about projects related to data collection. First of all, I will start with the process we usually go over when we start a data analysis project or data science project. Then after that, I will go over some of the projects I have been involved in. Some of the projects are solely related to data collection, how we can automate and digitalize the data collection process to make it smoother when we want to go for data analysis. Others integrated or utilize natural language processing and medical image analysis with machine learning. I will also go over some of the promising research area we're working in, and how machine learning can have like high impact in these and has a potential in these research areas. I will also discuss some of the challenges we faced while doing some of these research projects and what's actually required or needed to move some of these projects to clinical practices. So in general, when we want to start any research project, we start with defining our question, what we are trying to do. For instance, which genes are highly correlated with glaucoma condition? Another example would be using retinal images. Can we detect glaucoma in very high precision? And when we say very high precision, it would be similar to the precision in clinics. So we start defining our question, and this would sometimes usually broad questions. When you start conducting your analysis, sometimes you divide this into multiple sub-questions and you start answering these sub-questions like by each one by itself. Then after that, we start collecting our data. Now, during the process of defining the question and collecting the data, sometimes we start building knowledge. We want to see what other people were doing, what type of data was collected. Then when we start collecting data, we also ask ourselves what type of missing data. If data is present, what are alternative? If data is not labeled, can we use clustering approach to minimize the time needed for labeling, or can we have someone to label for us? Then we explore the data, and then we start cleaning it. By cleaning the data, we mean in some cases you need to move the collected data into be structured. Sometimes the analysis would be easier when you have structured data, and when you have this data structured in a way so that retrieval would be easier or more feasible and less time consuming. Sometimes when you clean the data, you translate categorical data to be binary data, because categorical data sometimes make issues when working with machine learning. There are some approaches that can override this, but some researchers prefer to have binary-based data. Then you start analyzing the data. When we start analyzing the data, we start detecting which techniques we want to use for to analyze this data. Is it like we want to use time series analysis of continuous data, or do we want to use image processing techniques or natural language processing techniques? And by experience, you start deciding. The decision of these techniques would come a little bit smoother, I would say, because you would know which algorithm may be suitable for which problems. And then during the analysis process, you start deciding, okay, I need to do tweaking for this algorithm, or I need to build a new algorithm to fill the gap in a research area. So this decision will be based on when you do the analysis and when you have the results. One thing that I realize a lot, when people start interpreting the results, don't like jump to conclusions pretty fast, because sometimes your results may look very good, but that's because overfitting happens. Overfitting is when your machine learning models works pretty well on a data that previously seen, but on new data it performs poorly. So make sure when you are doing the interpretation, you're doing it by answering a couple of questions. Did overfitting occur? Do I really know what's happening in the algorithm, or is the technique performing how it's supposed to perform? So these are just general steps usually we follow when we are conducting research project to make sure that the work is being done is recognizable and is good. Then after that, once you interpret the results, this question can be divided into multiple questions, and then you repeat the process and so on and so forth. In today's presentation, I will go over RCM project. This project was done in collaboration with the Health Child Uganda, and was used in Uganda for transforming paper-based surveys into the digitalized format. I'll go over the process of how we developed this and how this moving to digitalized process reduced the amount needed for data analysis process and expedited the process of data collection in Uganda. Then after that, using the idea from data collection from surveys, we came up into a question: how we can help non-expert users access this data. So if you want to get a report from a database, you need usually to ask a database engineer or someone who knows SQL to do the query for you and retrieve the data for you. But how we can eliminate this process to some extent so that non-expert users can write their question and retrieve related data from databases. And here where Query Builder comes. So we combine natural language processing with machine learning techniques to allow users to have like WH-based questions and retrieve results on that. And then the third project will be about glaucoma detection. Glaucoma detection is a project that works on analyzing retinal images. Now, these retinal images can be obtained from an expensive machine, and that's currently based in the clinic. But what we are trying actually to do is we're trying to have our model adapted to retinal images taken using handheld devices. This is a new technology that's getting more and more interest, and we're trying to develop some models to allow the analysis for images taken or obtained by these handheld devices. For this project, I'll be basically discussing mainly two components, because the other components are still work in progress. The components that I'll go over are mainly the disk region, how we segment it using deep learning, and the vessel segmentation, how we segment the vessels using also deep learning, and a study we did to label some of the data to train our models. So first we'll start with RCM. So RCM is a tablet-based survey system that replaces paper and pen methods for surveying people. So previously what they used to do is they used to go to the rural areas or villages in Uganda, and they used to have a complicated survey with more than 300 questions that contains sub-surveys and other sub-surveys. And these surveys will contain skipping, validation, and condition. And all of this needs to be handled by the person doing the survey. So what we've done is we eliminate this process from the person surveying, and we had this handled by a tablet, by a program we've built that can run on a tablet and can help in the data collection process. And this actually helped in expediting the process of surveying people. They were able to cover more households, and they were able to have the data ready for analysis in a very short period of time. So this was used for the first time by Health and Child Uganda to collect data from households. So the process for assigning surveys, there are 3 different people involved. There is first the supervisor. The supervisor is responsible for handling to which regions manager should be allocated. And say on Monday, for instance, managers need to go to region X. This manager need to go to region Y. And they assign this region, and then managers assign households to each research assistant. So supervisors are not usually on the field. Managers and research assistants are the people in the field. The research assistants are the people who are serving people, who are going to the households. Managers are monitoring the process, and in some cases they may reschedule some of the surveys to be surveyed again. There are different types of questions involved in this survey. These are some of them. They have multiple choice, single choice, single choice table-based questions. In some cases, you need to enter numbers, and we do all the validation for these questions. You have skipping. You have, for instance, in this question 205 in this diagram, is disabled because to be enabled is dependent on the answer of another question that wasn't answered in a way that will have this enabled for it. And there are like other types of questions that were integrated, and we build this in a very dynamic way. Now for each question we have a comment bubble. The comment bubble will allow teaching assistant to say or write some notes that they were encountered while doing the survey, and they believe that this note the manager should be aware, or the supervisor should be aware of. So these are like how does it look. Now for the evaluation process, at the end of the day, or for research assistants, at the end of serving each households, they go and check the status of the survey. Is there anything missing? Anything need to be rechecked again? Supervisors can evaluate the RAs, or manager can also evaluate the RAs, and they can check their performance and correlate it with the data collection process. Also, they can do bulk download and see the status of how many surveys were refused, were postponed, were completed, and so on and so forth. This will help them like when doing analysis and rescheduling some of the surveys to be surveyed again. So using tablets for this survey instead of using paper helped a lot on improving reliability of data with less time and effort, and has made ready for analysis. The success that was achieved in Uganda led to adopting this application also in Tanzania, which is also being used for the same purposes for data collection. It helped a lot in the way how data is being collected, and helped a lot in analyzing this data and deciding on which resources need to be allocated for these countries. Challenges faced are mainly related to replacement of damaged tablets, because in these rural areas, sometimes you may have tablets damaged. We try to take precautions as much as we can, but I believe we had 1 or 2 cases that tablets were damaged. The other project is Query Builder. Now, using, as we said, the idea of having these surveys stored, we need to find a way to allow non-expert users to access this data. So how we can do this? So Query Builder interface is a natural language interface that allows users to access data by just asking questions in a WH format. But when we say WH format, it means questions that start with what, who, and where, and so on. Another thing also we add is something called fuzziness. For instance, when we have a question such as, what is the number of people who have high service fee? This question includes a fuzzy domain called high. High for me may be 5K, for another person may be 4K, for another person may be 6K. How we can define this? We can define this by using the fuzzy membership function to see how each value is close to the high domain. For instance, 5K can be 80% close to be high and 20% to be close to average. And this is actually different than probability. Probability, when you say 5K is 80%, it means the chance of having 5K is 80%. But here we're just saying how close 5K is close to that domain. Now, the process for this project it starts by configuring a database connection. Now, this stage is maybe the only stage that needs information from a tech person, because you need the database connection information so that you are able to connect your backend. Now, we try to do it in a way so that it's smooth. Non-expert users, they can just ask for these questions, or they can ask the tech person to input this data form. Then we validate user input. After that, we analyze it, display results, and then we ask for feedback to see does this result correlate with what they were looking for or not. Now, this is the analysis process. We first start by user input. We check, is it SQL? If it's SQL, we check if it's fuzzy. For instance, if we have a query such as select salary from people where salary is high. Now, the phrase salary is high is fuzzy. Now, since we detect this, we go and process it as a fuzzy membership function, and we obtain the results. Now, it's not SQL, we check if it's a question. Mainly, we're just focusing on WH questions for now. Later on, we can expand this to other type of questions. Then we do some sentence refinements, get dependencies between words using artificial neural network, remove unnecessary words, map words with database schema, and filter selected tables. Then after that, we get select query type, build SQL, we make sure the SQL created is error-free, check if it's fuzzy, and then display results to user. Now, for sentence refinement, we use the Hans spell checker. In some cases, users may have on purpose put a spelling mistake. They want that to appear. They can leave it. Or if the suggestions provided for replacing misspelled words are not very accurate, users can add their own domains. We also detect date expressions, for instance, such as last 4 months, last 4 winters, and we replace that by the actual date. Now, we use for that the standard SU time model, which is based on rules and patterns built upon thousands of documents and emails. But what happens with SU time model is that in some cases, when you have last 4 months, it's able to detect this and it's able to detect it to a date. But when you have a phrase such as last 4 winters or last 4 days, it will be able to detect it as a date, but it won't be able to detect it to replace it by an actual date. So we need to handle this on our end. Another thing is we replace numeric-based numbers into actual numbers, and this was actually through using the dependency parser. So the dependency parser will extract the relation between numeric words and their units, and then we use this information to make sure we extract the proper number. We transform it into the proper number, and then this proper number, we make sure it has a relation with an actual table or column, so that when we're building the SQL query, we're doing the proper mapping. For the fixed negation, we have contractions. We try to transform contractions to be uncontracted, because this will help us when building also the dependency and the SQL query. Now, for extract dependency, we use the Stanford NLP model. The Stanford NLP model uses artificial neural network with multiple hidden layers to extract dependency between words, along with something called a part of speech for each word. Is it like adverb, adjective, noun? And we use this information to build the SQL query to retrieve related data. We also remove unnecessary words, stop words. We remove punctuations, and we just keep the words that we think need to be mapped to a table or column. Now, how do we map words to database schema? First, we use a scoring system to decide this word, how much is close to a column or a table. Then after that, we use our own ontologies, and the last case we use name entity recognition. For instance, if you have the word Abid in your question, Abid is like a value, is a name. So we go to the name entity recognition. It will tell us this the type of this word is a person, and then by knowing the type, we would be able to know to which entity this word will be mapped. And for name entity recognition, we use the conditional random field classifier, also developed by Stanford, which was trained also on thousands of documents to handle such tasks. The name entity recognition only handles person, location, and organization. There is something called miscellaneous, but that's something else that when this happened, it means it wasn't able to detect the type of the value there. Then after that, for the select clause, we check the question type, if it's in numeric, if it's quantity, if it is normal select statement, and based on that, we select the format, or it's on the format of the select statement. Then after that, we select the from clause. We make sure every column present in the selected clause is available in the from clause as well. So every column in the from clause, if we have multiple tables in the from clause, we make sure we have inner joins. Now in the selected clause, we can handle aggregate functions as well. For instance, select count star. But the thing is, we don't handle filtering on the aggregate function. That's something else that we need to add in the future release for this project. Now for the word clause, once we have the word clause and the select and from clause were handled, we work on detecting fuzziness. And the fuzziness will be using a membership function that will be that's defined by us, that shows how much close a value is to a specific domain specified by the user. Some operators handled by our system are like between, less than, higher than, average, maximum, highest, equal to number, for instance, highest, lowest, and so on. Now for handling the fuzziness, we have three different ways of handling fuzziness. The first way is the manual method. By the manual method, we mean the user specify the domain. The user may have 4 different domains: high, mid-high, average, low, for instance, and they decide the ranges of these domains. For instance, high can be from 5K to 8K. Mid-high can be from 3K to 6K, for instance. And this intersection between 5 and 6K is where actually the fuzziness occurs. Semi-automated, the user specifies their domains and we specify the ranges by using an equation developed for these purposes. The automated one, we specify the domains and specify the ranges. By default, the domains are 3. Here's an example of how the fuzzy membership function or fuzzy membership looks like. In this project, we use the triangular fuzzy membership. There are other membership types such as the trapezoidal membership, but that's it can be used also in later in future versions. So here we have 3 domains: low, mid, high. Low is from 0 to 20. Mid is from 10 to 50, high is from 40 to whatever the highest value is. So basically here there is intersection. For instance, between the low and the mid, we have 10 and 20. So this is an intersection. So here we try to show what's the fuzzy membership for each value between 10 and 20, and we show that to the user. Now there are 3 different points that we need to take into consideration when building the fuzzy membership function. The first one is the lowest value, the second is the centroid, which is the middle, and the third is the highest value. And based on where the value sits between these 3 variables, the membership function will be created. So let's assume x is the value. If x is less than a, then it will be 0. If x between A and B, then this how we calculate the membership function value for X. If between B and C, this is how we calculate it. If it is greater than C, then this is how we calculate it. Now, to calculate or to measure the performance of our system, we ask a person to design a database and then ask people to define a list of questions that would like to retrieve data for. Then we measure the data, we measure the accuracy of the data retrieved, whether it matched what the user were looking for or not. So we split the questions based on their types. Simple, it means they used only one table and one work condition. Complex, they have multiple tables, joins, and multiple work conditions. And we have fuzzy, where fuzziness were involved. And we achieved around 90% accuracy in properly achieving these and properly answering these questions. As for system performance, with interaction, it depends on how interactive the person is with the system. So on average, it took around 0.8 seconds, because in some cases we ask the user for questions so that they can correct some of the words or fill some of the missing information needed. Without interaction, is almost the half. So in general, it performed pretty well. These are some screenshots. So on this one here, so the user can upload a JSON file where they have all the information they need, or they can create a new project. We also added like a helper function, a helper model that can help them or guide them through the process. Here also we show the user the structure of the database and how does it look like, so that they can have an idea of what information is available there. We also, here in the backend, we have save and download, so that if they want to save the results or they want to download it, and we have also management forms so that they can define their spelling words, they can provide synonyms, antonyms, they can provide fuzzy domains. Now, how does the output looks like? So here how the translation happens. So here, for instance, how many service reviews exist in the database. So we define the quantity, the question type, which is quantity, and then we generate the SQL. Now after this, there will be the list of data being retrieved. So we show the user the SQL generated from their question so that they are aware how things are working. So as a summary for this project, we build like a query builder to allow to retrieve data from databases without prior knowledge of SQL. One of the things in this project is that it relies if there is a schema stored for a database. Now, if there is no schema designed for this database, then we may need to do reverse engineering to generate our own schema, but that's also in future releases that can be handled in our limitations here. Some of the limitations that we need to take or to handle in future releases as well, such as advanced rule of fuzziness using grammatical relations. So now we use only noun or verb, but we believe using the information that a word is adverb, adjective, and other grammatical relation would help in improving the decision making. Using aggregate function. By using aggregate function, we mean using filtering on aggregate function and handling non-question based text. Future work also entails supporting multiple languages and speech recognition. By speech recognition, we mean the user would be able to ask question using their voice, and then we take that data, translate into text, and then do the analysis after that. The third project I want to cover today is about glaucoma detection. Glaucoma detection is the world's second leading cause of irreversible vision loss. The term glaucoma refers to a condition where retinal ganglion cells have been damaged. And now the key in glaucoma is that once the damage occurs, you can't restore that vision loss. And the key in it is early detection. 80% of the cases are untreated or undetected early because for various reasons. Sometimes inaccess for vision care, sometimes it's the improper referral, and so on. So it's a very important issue that people are actually facing, especially in the developing world. One of the main conditions leading to glaucoma is increase in intraocular pressure of the eye. So when the pressure in the eye increases, it causes blockage for some of the drainage in the eye, which will cause damage to the retinal ganglion cells. But in some cases, you will have a normal pressure but still have glaucoma. And they're trying to understand this by using by understanding which genes can be correlated with the damage of the retinal ganglion cells. How the progression of glaucoma starts. First of all, here this image, normal vision, is how a normal vision looks like. And then there are different stages until you have this peripheral vision loss. Now, once this peripheral vision loss happens, it starts advancing to be advanced and extreme. And in many cases, the detection will happen in the advanced case or extreme cases. Sometimes a little bit before, but in many cases, early glaucoma are usually not detected. To build this project or to work on this project, we first started by checking what's available there, what type of data is available there, what type of techniques are available there. And to do that, we built on the experience we had with the natural language processing and the query builder. So we used some of the techniques used there to go and get all publications related to glaucoma in online repositories. Then after that, we analyzed these publications and we checked what is the trend in this field. And we checked which top countries are working on glaucoma detection, who are the top authors that are working in this, and so on and so forth. And based on this, we ended up with having with around 150 publications. We analyzed the techniques in these publications, and we published our results. And then a next step to discover more challenges that's being faced in the research, we did performance analysis for 4 approaches. For these 4 approaches, we obtained the code, and we tested it on the data sets different than what they were tested on in their studies. And we found so many limitations for so many issues when handling retinal images obtained from different resources, such as like having some artifacts in the image which are not handled, or some of them they are threshold dependent, which if you have another component with the same bright region, you won't be able to properly detect the disk. And also we published our findings in that. Using the information obtained in the background, we were able to develop our methodology and be able to know in each component of our methodology what needs to be handled to make sure we're filling the gap in the research. So first we started the background, then we decided, okay, we need to do vessel segmentation, because vessel segmentation would help us in 2 ways. First, in detecting the disk center, which will help us in eliminating some of the artifacts in the image. Other one, there are some studies that report the thickness of the blood vessels near the disk region can be highly correlated with glaucoma. So we needed to study that as well. Then after that, we work on disk segmentation. The third component will be on CoP segmentation, and then glaucoma detection. Glaucoma detection uses the disk, the vessels, the CoP, and also we analyze the surrounding region to discover other components such as pupillary atrophy, which has also been studied to have some correlation with glaucoma. So the first 3 are conducted. The second 2 are still work in progress. So I'll be going over the vessel segmentation and disk segmentation and the study we conducted for analyzing, for obtaining some labeled data. So for vessel segmentation, one of the issues we face in vessel segmentation is that there is no available enough data sets. So in publicly available data sets are around 150 images, and 150 images are not enough to train it on a deep learning model, because we realize using handcrafted models are not always the best practice for vessels. So we said, let's add another data set. We added around 52 images, and in total now we have 202 images that can be available for the researchers to use and advance in this field. And to be able to handle also the low number of images we have, we use the generative adversarial network deep learning model, because GAN can work on small number of data sets and yet still achieve acceptable results. So first we input the retinal fundus images. Not like other approaches, they use one channel, which is the green channel, for segmenting the vessels. In our case, we use information obtained from different channels from the images. We pre-process, we do normalization, we do adjustment of the contrast, and then we train our vessel segmentation, GAN, and then we output the results. Here is some of the output. The leftmost is the normal retinal image. The one beside it is the ground truth. The one beside it is the output of the GAN model. And then we do a morphological operation because we're only interested in thick blood vessels. And using this information from thick blood vessels, we will be able to analyze and see if there is difference between glaucoma people or normal people. Then after that, the second step is we want to build a model for disc segmentation. Now also, disc segmentation also suffers from the issue that there is not enough data sets, but not like the vessels. So when we started with this, there were around 1,500, I would say, images for this, but also they weren't enough. So what we've done is we added another 500 images from a private clinic in Calgary. And we asked 2 optometrists to trace these images using an online portal we built for such purpose. Now, the purpose of this study was, the goal of this was 2 things. The first one is collecting some labeled data for our deep learning model. The other one is for checking if there is variation in tracing between different optometrists. So 2 optometrists would trace the disc using the online portal, using their tablets, phones, any mobile device. And then they were evaluated, and inter and intra-agreement will be calculated. And those who have a high disagreement will be evaluated by an ophthalmologist experienced in glaucoma. We found there is high disagreement, especially in the ones that are related to glaucoma, basically because the border wasn't very clear in some of the images. Other ones will be the experience of the optometrist. Here's the portal where we assign images for domain experts, and then after that they can trace it. Now after that we have around another 500 images, and we build our disc segmentation. For disc segmentation, we follow the same process we followed by the vessels. We use the 3 channels, not only one channel. We apply some pre-processing, but in this one we use VGG16 model. And with VGG16 model, we use something called transfer learning. We use a pre-trained model, and then we customize the VGG16 to match our problem, and we train it again using the data that we have. To avoid overfitting, we use K-cross validation, and we use data augmentation and randomness on every training iteration, which is called epoch. And then we segmented the disk. We tested our approach on 9 publicly available data sets. This PC is our private data set, which will also will be available for researchers working in this domain. So if you can see, for each image there are different, the angle of the disk is taken from different regions, from different angles. So this one here in PC, you can see where the disk is located. In Drishti, you can see where it is. In IDER, it's more to the left. In REM, you can see where it is, and so on and so forth. And you can see how our prediction was very highly accurate in detecting these disks. We actually achieved like a DC of 95%, which is pretty good when working with disk segmentation and with the variation of images we had from different clinics. So takeaway is that vessel segmentation is a limited number of images and deep learning. So we use GAN to handle this. But one other thing that we need also to add, we want to see if there are other approaches that can help in improving the detection of the vessels, because GAN requires like very high computation. Some approaches they use UNet, but to use UNet you need a higher number of images. And one of the things that can be used is using patches. But when using patches extracted from images, you're losing a lot of information from the image, and that would make the learning process of the model pretty slow and not accurate. Now, one of the things we're trying on top of GAN is using ResNet 50 with transfer and learning, and we believe that will perform or achieve very good results. We found high disagreement in properly detecting disk border. This agreement is mainly in glaucoma images. Disk segmentation using data augmentation and deep learning. One of the limitations we had in vessels is ability to handle small and thin blood vessels. This, we will see if we can handle it when working with ResNet 50 model. Some of the promising research area using portable devices. So for now, for retinal fundus images, they use pretty expensive machines in clinic. Recently, new innovation is getting interest or getting attraction, which is using handheld devices. And using handheld devices, you can produce enough information that's required to detect glaucoma. And the model we're building it toward such type of devices. And we are in the next 2 months, we will start in the testing process on these handheld cameras. Another one is sometimes training residents on special surgeries is pretty expensive. So going toward virtual reality would reduce the cost and will improve the experience that residents may have in while they are being trained in the residency program. Another one would be gene pathway analysis. One of the things that's interesting now that can be very effective is, for instance, like extracting genes from abstract, building network from genes, and doing pathway analysis between these genes. There are multiple publicly available gene repositories that, given one gene, you can find all connecting genes, and you can find like synonyms, aliases for these genes, and the position of the DNA, and so on and so forth. And you can also find the drugs that are related to this gene. So all of this can be built on a network, and social network analysis can be achieved here. Especially when, like for COVID, this can be a very interesting topic or analysis that can produce very promising results. Another one would be drug repurposing. Drug repurposing, which means a drug that was used for another disease, it can be used for handling or curing other conditions without like spending a lot on discovering this drug. Now, what's required to move this project from clinical to bed, from research to clinics, is that first of all, you need diversity of the data. Most of the available approaches there, they just test their approach on 2 or 3 data sets. They are not very diverse. So you need to make sure when you're testing your model, it's diverse data sets. You're handling, you know where the challenges occur, and then you may put like a cut of values, or you can mention which images can be handled. But diversity of the data sets is very important to show the robustness of your approach and the reliability. One of the things that can be also used is mixing handcrafted techniques with deep learning. So deep learning by itself performs well. Handcrafted techniques can perform well on some of the handling some of the issues, and they are less cost effective than deep learning. So mixing both would help in solving pretty complex problem. Now, the main thing when moving to clinics is making the technology smooth to be adopted by clinics. Clinicians, they don't want something that can increase their workload. They need something like to have their work goes easy and let them focus on other things. And one of the things that you need also like to show them that the tool that you're presenting is mainly like decision support system. You're not replacing the physician or the health doctor, but what you're helping is you're helping the doctor in improving their diagnosis for a specific condition so that they can focus on other components in healthcare. One thing also that you need to show is don't let the model work as a black box. So don't just show the end user, okay, you have glaucoma. You need to show why they have glaucoma, why the system made such a decision. For example, in our case, we will show what's the cup-disc ratio that was calculated, what is something called rim area, vessels in the rim area, how that was used. We will show the features that were highly correlated with glaucoma detection in the disc region. So all of these, when you show them to physician, it will build some reliability or some trust between the decision you're making and the analysis that was made. So basically this is everything for my presentation. I hope you enjoyed it, and thank you for attending today's presentation. If you have any questions, feel free to ask me.
Great, well, thank you. Yeah, let's open it up for questions. I see a few questions in the chat window. Do you guys want to just verbalize the questions to Abdullah?
Abdullah, it's Grant Gillis. I was interested in particular in the last portion of your presentation with the gene pathway analysis for better understanding of glaucoma. Can you maybe expand a little bit about that and what that involves, even early state where you think the research will take you?
So basically, one of the things that we've done for this topic is we went and extracted genes reported in the literature that may have a potential with glaucoma, and we gave them a score. Now this work is still in progress. So what we've done is we took these genes and then we tried to build the network or the interaction between these genes, and if there are other genes involved in that network. And then after that, once we build the network, we apply something called social network analysis for analyzing this network. We just want to see which genes is highly connected to all other genes, which genes are correlated to some drugs. And doing that would help us to know if there are some drugs that can trigger, for instance, the death of retinal ganglion cell in the image, and so on and so forth. So, like, the key in this is just build the network, and then we analyze the network to detect which genes can be highly related with glaucoma, and if there are some hidden genes that we don't really know of.
Right. Thanks for that. Appreciate it.
You're welcome.
Bandwidth challenges that you ran into? Obviously, like, I think getting the data from the end devices all the way to the server is challenging, where networks are up and down, power challenges and things like that.
For the Uganda project?
Precisely, yes.
Yeah, so basically for that one, we made our application to be somehow internet independent. So what we've done is for each tablet, we created like small database that can keep storing the data. And in the end of the week, there used to be a person who comes with a USB dongle, and they attach it to a laptop, and then all data will be synced with the online server. So research assistants can still work on data collection. Managers usually assign households on a week base, and at the end of the week, USB dongles will be attached, and then they will be synced with the server.
Interesting. That's great.
Welcome.
Can you go through, Jesse here again, is it possible to go through, oh, actually there's a question in the chat window here. So regarding your literature review, would you mind sharing your findings? Were you using UNIC convolutional neural network in detecting optic disc and cup segmentation?
So we realized UNIT didn't produce very good results. I've tried UNIT on disc segmentation. What happened with UNIT is sometimes was converging toward other bright regions. It was also in some cases it was mixing PPA, which is something like it's some of the indicators of glaucoma that's attached to the disc. So we found UNIT didn't perform well, so we moved to VGG16. But VGG16 by itself also like it performed better than UNet, but to improve the performance of it, we use something called transfer learning. We use a model that was pre-trained on ImageNet, and we customized the VGG16, and then we used the weights generated by ImageNet as a starting point, and then we train using our data set, which led to, at the end, to 95 dice coefficient value.
Hi, Jesse, it's Mark. I have a question for Abdullah.
Yes.
Hi, Abdullah. Thanks very much for the presentation. I apologize. I had to join late, so I missed the beginning. And if you touched on this, I apologize to everybody, I guess. But so I do see a lot of application of deep learning methodologies to imaging opportunities, as well as natural language processing. One of the areas that we're dealing with is how to validate the application of these methodologies by, particularly with industry, to deployable products, right? So there aren't a lot of those yet on the market that have been approved. I think the regulatory bodies are still trying to sort that out. But I guess I was curious about your thoughts on how health systems can validate algorithms have been trained on different patient populations in other countries or even in our country. And how do we go about managing, this might be beyond, I guess, your area, but what would be your advice about how do we prepare ourselves to assess these algorithms and determine whether they will have as high a predictive validity against our patient population when wanting to use it for clinical use?
So basically, one of the things that I'm using actually is obtain data from different countries. So I obtained a diverse data. So now I have data from Canada. There are like 8 publicly available data sets obtained from other regions in the world. There's one from Turkey also as well. So I obtained a diverse data set, and then what I do is I try to segment the components, and then using like for images, it's very important to use the dice coefficient intersection of a union, and you try to see what's the performance of it, and using that performance, you would consult with a domain expert and show them, what do you think this would perform with a normal person tracing it? And they would be able to make decisions. That's one thing. Another thing is you need to show how the decision was made. And some of the technologies or some of the developed approaches, they just produce a final output. Okay, this is glaucoma, this is not. But usually people in clinic or physicians, they're not interested only in this. They need to know what they've missed when detecting this image, what information they were used for this analysis. So that's what need to be also visualized for user. And one thing also that I believe there was one relating for diabetic retinopathy that has like FDA approval in US. One of the things they mentioned is that it's decision support system. Like right now, the technology for deep learning in healthcare is not ready to make decision-making system, especially for conditions such as glaucoma, diabetic retinopathy. So it's more like decision support system. At the end of the day, the physician will decide if the output is accurate or not. So these are different measures we usually use. And I'm actually now in contact with some of the local clinics to do some clinical testing for the glaucoma detection process. To see how this can really be effective in their daily life and help in early detection of glaucoma and saving vision loss. So this answers all your questions, Mark?
It starts, right? I think there's a lot to unpack, and I know, Jesse, I appreciate the community of practice you've created, because I think we're going to need a lot of eyes and ears and critical thinking, problem solving around how do we go from the discovery. So on the discovery side, I think we get lots of requests to use our data to train or potentially train algorithms or see if there are patterns that will provide signals that we can't normally detect. and I'm less worried about the discovery side. It's more around how do you then convert those into decision support tools like you were alluding to, Abdullah, and then how do you manage the biases both on the trained data set that was used by the entity that's offering it, the vendor, as well as potential inherent biases in our own data, right? So how well does the fit of our data systems apply to the algorithms? And we're not there yet, I guess, but those are the things that my team is considering are on the next step, right? Because I expect our vendors, our researchers will be seeking ways to convert what they discover into decision support tools that can make a difference. And we're all anxious, I think, to try to do that and extend what we can do using these pretty amazing technologies that we've been able to generate over the last 2 decades.
Yeah. So to add on top of that, like I believe when you have a diverse data set and the way that you train your model is one of the key factors that can limit bias in your decision. Sometimes you may involve other clinical factors that you think may contribute to the results, but that's also will be down. Like the first step would be generating a model, for instance, for glaucoma detection. Then after that, see how that would perform in clinical practice. Then you may do some adjustments. You may add some other information that are important when doing glaucoma detection and help in reducing the bias in your model.
Well, my internet died. So my internet died, so here we are. Well, thanks everyone. I assume, was there any other questions? All right. Well,